Now this one is slightly tricky, but once again I'll say that this is doable. Okay, though we have kept this question in the level of difficulty higher, but I would say that this will be somewhere between moderate and high level of difficulty if you will do this question very carefully. Now in this set of numbers from 23 to 57, I want to select two of them such that the sum will be a multiple of 3. Now, if I write some integers, then the sum of two numbers will be a multiple of 3 in two different possibilities. If both the numbers a and b, which I'm adding, both are multiples of 3, okay, so this is in the form of 3k, this is in the form of 3k, that means both are multiples of 3. Or there may be another possibility when one of the numbers is in the form of 3k plus 1 and the other number is in the form of 3k plus 2. So these can be the two possibilities in which two numbers, two natural numbers, sum up to a number which is a multiple of 3. Alright, so this is what you need to take care. So first of all, I'll segregate the given set of numbers in the numbers which are multiples of 3, the numbers which are 1 more than multiples of 3, and numbers which are 2 more than multiples of 3. So let's take it as the first step. So first of all, write all the numbers which are of the form 3k. That means multiples of 3. So in this range of numbers, the first number is 24 and the last number is 57, which are the multiples of 3. Okay, so counting all these numbers, so you can use the formula for AP, right? Nth term of an AP is a plus n minus 1 into d, and you can calculate the value of n, right? Or you can do it logically. So 24 is the 8th multiple of 3 and 57 is the 19th multiple. So starting from 8th multiple up till 19th multiple, there will be 12 numbers which will be multiples of 3. Okay, logically I have calculated this. You can use the formula of arithmetic progression as well. What logic I have used is this is 8th multiple of 3 and this is 19th multiple of 3. So I'll have to remove first 7 multiples. So 19 minus 7 is equal to 12. Okay. Now next is the numbers of the form 3k plus 1. So the first number of this form is 25 and the next number will be 28. Obviously there will be at a gap of 3 and the last number will be 55. Okay. So 25 is 24 plus 1. That means 1 more than 8th multiple of 3. And this is 54 plus 1, 1 more than 18th multiple of 3. So 8th and 18th, I need to remove first 7. So 18 minus 7, that is 11 numbers are of this form. Next, the numbers which are of the form of 3k plus 2. So the first number here is 23, next number will be 26 and so on. And the last number will be 56. Once again, 23 is 7th multiple of 3 plus 2. 3 into 7 plus 2. So 7th multiple of 3 plus 2. And this is 18th multiple of 3 plus 2. So the number of numbers will be 18 minus 6, that is 12. So I have segregated the numbers which are multiples of 3 or of the form of 3k plus 1, 3k plus 2. Okay. Now I need to select two numbers such that their sum is a multiple of 3. So case number 1, when both the numbers are multiples of 3. Okay, so out of 12 numbers, number of ways of selecting 2 will be 12C2 and that will be 12 into 11 divided by 2, which is 66. Alright, the second case is when one of the numbers is from here and another number is from here. One of the numbers is 1 more than a multiple of 3 and another is 2 more than a multiple of 3, then their sum will be definitely a multiple of 3. So one number from this set of 11 numbers and another number from this set of 12 numbers. So 11 into 12, that is 132. So total number of cases will be 66 plus 132. So 66 plus 132 is the total number of ways I can select two numbers such that the sum is a multiple of 3. Adding these two, the final answer will be 198. And that is the final answer for this question. So after knowing the solution, I believe that you would not uh, keep this question in a category of high level of difficulty. So it can be moderate to difficult. Okay, so that was question number 9. Let's move towards question number 10.